Yes. Today our topic is to learn about the basics of the function. Right. So we are going to learn about functions. Functions. So we know that today, what do you mean by a function? What is a function? That's a problem we come across today. So when you are talking about it today, so you can say it is a relationship between input values. Input. In functions or in mathematics, we call input as a term called domain. Domain and output values. Output values we call as codomain or general use is range to it. Range and output and input. So you can see not only function, any relationship is a some kind of a function, right? So in this case, you can say that like this. Suppose that there are some kind of values are there. For example, they have given fx. Fx equals to x plus 3. If x is minus 1, 2 and 3. What is this? If it is x equals to minus 1, it's 2. 2 will add it, turn up to 5. 3 means it's 6. Like that, this is a relationship. It's a relationship. Relationship. Right. Is that clear, children? Can you hear me properly?
Yes, sir.
Okay. Then today, my question is this. Right. I'll read this because this session is recording. Therefore, you can just complete up your note later. Then, my question is today, are all relationships become functions? Yeah. My problem is that today, if you get like all the relationships, can it become function? From your general idea even, can you say?
No,
All
sir.
relationships become function for a while. Forever.
No, sir.
Or relationships never functions forever. Because you know that with the time being, it can have some kind of a breakup. Right. So if there's a breakup, it's not function further. Same way in mathematics even today, all relationships cannot be a function all the time. Right. So you can say for any relationship to become a function, it must satisfy two conditions. Yeah, that is a theory. So any relationship to become like, so for example, in our day-to-day life relationship become some kind of a function, it has to be function forever. You have to satisfy two conditions. Just like you can say, all of these things are the beauty of the nature. So like same thing, you can see to become any relationship to be a function or to become a function at all. So it has to satisfy two conditions. First question is, for all input values, domain, input values, there must be an output value. Right. So you can say, for example, if you want to keep a relationship forever, whatever the question they ask, you have to answer. Is that clear? So whatever the question, input, which inside input to you. So sometimes, for example, a relationship between some kind of a girl and a boy. So all the questions where the girl asks, the boy must have some kind of an answer. Other than that, if it is if you answer, if you are not answerable, definitely that is the start of the breakup of this function, right? Okay, so always make sure that you need to find some answer for all the input values. In mathematics, even same, right? The second condition. The second condition is one input must have only one output. That is obvious. So you can say if you have a one input means one person should have a relationship to only another person. If you have like one person is having 2-3 relationships, what happens to it? Definitely it will break up at the end. So one input must have only one output. Right? So these are the two facts where it should satisfy to become any kind of a function. Today I'm going to mainly focus on in these functions how to find the domain and how to find the range for a function. So under this situation, you can say if it satisfies these two conditions, we can say it's a function, right? Okay. Right. Now let's go ahead with this section. Right. Then the next part of it, for example, we'll get some kind of like functions and see whether these functions are really become functions. So is there any deviate? This is just a relationship, but not a function. For example, if you get this kind of it, if you get fx is equals to x plus 2, and they have given the domain x is any real number. X is any real number, right? So we can say that whatever the number you input here, whatever the number you input here, you get only one output value. So this is a function, not a problem at all. Okay. So this is function. So it satisfies whatever the input value, you can get an output value. So for this function, and the other one is today, one input has only one output. Right. Okay. Then our next condition today. Our next condition is this. Right. This the next function, gx. Now tell me whether this is a function or not. X is any real number. Is this a function?
No.
Or it's not a function? Yeah. What do you think?
No, sir.
Yeah. So if I go ahead with this, if I sketch this graph, you can understand that the graph is like this. Or if you substitute 0 for the g0, what is the answer to this? 1 over 0, it does not exist. Therefore, this is not a function because when x equals to 0, the function does not exist. So simply you can say, since at x equals to 0, the function does not satisfy, that the value does not satisfy, therefore this does not become, it's not a function. Right. Then if I get this example to say, hx is 1 over x, and they have given x is any real number, and they have given x is greater than or equals to 2. Right. That means if you sketch this function, it starts from 2 only. So the graph is like this way around. It's only this part of it. 1 over 2. Right. So, but you can understand from here today. So you can simply say that over here, this is a function because for the given range, there is no contradiction. Only one solution for all x values. For 2 and above, for whatever the x value, the function, like you can find an output figure. So this is a function. It's not a problem with this. Right. Okay. Right. Then let's go ahead with the third one. The next one is y equals to square root of x. Right. Then they have given x is any real number. Right. Then what can you say today? There is a two contradictions you can say. I will get this one as mx or something. Then you can say m minus 1. If I put minus 1, what would be the answer? Square root of minus 1. So it does not exist. The third case is whatever the negative values, it does not exist. Then the other fact is if you draw the square root graph, square root of graph, this is the fund value of it. So you can see at x equals to, if I get 4, you get how much? 2 answers, plus 2 and minus 2. So that one also, it's not, you can, so you can say for one input, the relationship get shows 2 values. Therefore, under these circumstances, we can say this is not a function. So here this one also you have to keep thorough in your mind. Right. Okay. Then I'll do a small extension for this function. Right. I'll erase this bit of it. Then I'll do another small extension with that, this one. So they have given x is greater than and o equals to 0. Then you can see whatever the value greater than 0, if you substitute in the function, there is an output value. For all values of x which is greater than 0, we can obtain an output. That means for the first condition, okay. First condition satisfies. But you can see but there is a problem. But for one input, what happened today? We can observe 2 outputs. So under this condition, what happened today? This is not a function. So you cannot say it's a function because for one input there are 2 outputs in this example. Right? So under these circumstances, we can say this is not a function. Right? Okay. Then the next extension, I'll come up with the next extension of the same function. It's just like this. They might give you a small difference somewhere like this. They have given nx is equals to square root of x plus. Now we are worrying about only, they are considering only the positive square root of it. That means if you draw the function, it's only this part of it. We are worrying about only positive answer. So for whatever the x value is more than 0, the function exists. With the meantime, for one x value, you get only y answer, one y value. Over here, if I get 4, it's only plus 2, not only the plus square root they are worrying about. So under this condition, we can say it's a function. So that is the condition where we should know under this section. Right. Yes. That is the way of understanding the functions. Right. Okay. The next case is identify the domain and range. Identify domain and range. That's the important point where we should know. Identify domain and range. Right. This is a way of doing it. Initially, if you give a function fx is equals to x plus 2, you know that there is no contradiction. for the domain is x can be any real number. There is no problem at all, because whatever there is no condition about substituting x values into the function. Whatever the x value, you can get an output value. Therefore, the domain becomes any real number, right? Then the range. What can you say about the range? For this function, the range also, there is no contradiction. Range also can be any real number. So there is no restriction for this function, right? Okay, that is how you need to understand the domain and the range for this kind of function, right? Okay. Then I'll do a small extension for this question. It's just like this. They might give a question like this. They might give you a function and the domain they have given, and they have given x is greater than 3. Right. Greater than 3. Right. We need to find, the question is, find the range. Find the range. Yeah. How do you find the range for this kind of a function? So initially, if you draw this graph, you can say it's a graph from somewhere like this. It travels to 2 and minus 2. It's a straight line. But this function exists. So these are y values. Domain range is the y answers x. So the function start from where? Function start from 3 onwards. If you put 3 here, what is the function? What function value is 5. Then the function exists only this here. From here only the function exists. That means what you can see, the y values. Y values are here onwards. You can see the y values only here onwards. These are the available y answers. Right. Okay. So you can say y start from 5. Therefore, you can say the range. Range is equal to, you can say fx is any real number, and you can say fx is greater than 5. This is not greater than equal, it's greater than, because here there is no equal mark, there is no value. For 3 onwards only the function exists. Right. That is how you need to understand this question, right? Yes. Then I will do another small extension for this question. These are the variations of the question they ask in this section, right? Then they might give a question like this today. -2 to
Sir?
+3. Yeah. Yes, Pita, buddy.
Sir, we write as fx is greater than or equal to 6.
Greater
The
than
range.
equals. Yeah, wait, 1 second. The same question, Pita, if they ask you this way, that's a question you ask. X is greater than or equals to 2. Or somewhere like this 3. So you can say in that case, the 3 is included. The graph is somewhere like this. It's passing through 2 and -2, and we just work out the 3. Therefore, 3 is included, right? So here 3 also included in the function. It's a function. Therefore, in that case, including this value, including the value 5, it's there. If you write the range for this function, you be getting the answer. You can say fx is any real number, and you can say x is greater than or equals to 5, because equal mark is here, means the 5 value also available in this function. That's a way of getting the answer, including with 5. Okay, that's how it comes. Right. Then let's go to the next extension. The same question they can ask you this way. X is in between -3 to +2. Yeah, +2, right? Then if I sketch this graph today, just like this. This is 2 and this is -2 at -3. At -3, I will remove the equal mark from here. That -3, what happened? The answer is -1 today. At 2. At 2, the answer is 4. Now you can say here, there's a equal mark is not there. Here the equal mark is there. That means -1 is the y values are here to here. Here to here, but there's what is the condition today? -1 is there. It's here, but this value is not there. Therefore, you can write a range. You can say fx is any real number, and you can say fx is greater than or equals to -1, but less than how much? Less than 4. That would be the answer for this question. Right. Let's go ahead with the another question. Right. Then they might give you a question like this. Gx is equals to x squared. We will get -10 3x. Right. Then they have given us the range. Sorry, domain. X is any real number. Right. The question is find the range. Find the range. Okay. This is a way of getting this. Then if I sketch this graph, you can understand that today here. Yes. It's a graph. This is, if I factorize this, it's turn up to x plus 5, x minus 2. Therefore, y-intercept is -5 and x-intercept is 2. Right. So if you go ahead with this, it shows a minimum graph somewhere over here. The intersection is the y-axis. Intersection of the y-axis is -10. Then the minimum value obtained at the midpoint of -5 and 2. So that become it occurs at -3/2, and the y value is the important point today. If you put -3/2, that value is -12.25 today. This is the important point where we have to understand. -12.25. Right. Okay. Then how do you get this? The range today. Range means the y value. So you can understand that today. What are the y values? Here the y value is here. Here. Like this it goes here, 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 here. Like that it goes down. Still goes down because of this one here. So you can see after that there is no y values exist. Therefore the y value exists in this side. Up to where? Starting from here, including that value, it goes up. It goes up to where? This goes up to infinity. This goes up to plus infinity. Therefore, you can write the range this way. You can write Gx is any real number, and you know that Gx becomes more than -12.25. Then you can say Gx is greater than or equal to -12.25. Yeah. So that is the answer for this question. Right. Okay, right. Then the next part of the question. I'll just do a small change in this question without making the basic. They might give you a question like this, but they might give you this is hx, and they have given us the domain. X is greater than or equals to 1 to. That means this is the function, right? From 1 onwards only you can see this answer today. If I substitute 1, what would be the answer? 1 plus 2 is 3, it's 4, 4 minus 10 is minus 6. Then this value is minus 6, right? Then we can see this part of the function is not there. This is not there. This part of the function is not there anymore. Function is only this bit. Then this is the part of the function. Right. Then what are the domain? What is the range? Sorry. What are the available y values? So you can say available y values are this bit. Y values. So you can say this way. Hx is any real number, and what you can say, Pratik? Hx is greater than or equals to where? Greater than or equals to minus 6. That would be the right answer for this question. Right. Let's go ahead with another question. Another part of the question. Another variation of the same question. So they might give a question like this. X is in between minus 6 to plus 3 plus 4 or something. So you can say x minus 5 and 2. The graph goes like this way around. Then here the value is minus 12.25. Then we need to answer minus 6 to it. Minus 6. If I get the value for minus 6, what would be the answer for minus 6? Minus 6 answer is, so I'll get some kind of a closer figure for that. Minus 5 and minus 6, it's a value here. So if I put minus 6, what would be the answer today? It's not in drawing a proper scale today. I just did this, so just please just for that. If I put minus 6 over here, so that value is 8 today. Then for 4, if I put 4 here, 4 squared is 16, plus 3 into 4 is 12, minus 10. That value is 18 today. Right. Now you can see this part of the function is not there. This is not there. Right. Then the function starts from here. Then if I start to draw it, it starts from here. It goes down up to here again. Comes up to where? From here the answer stops. From here the answer stops. Therefore, what you can say about the range today? Then you can say hx is any real number, and you can say hx has a range. Where to where? Hx is greater than or equals to minus 12.25 and less than or equals to how much? That's the answer for this question. I think you can understand how I get this part of it.